Okay, I posted this, I guess, this morning. So this is the standard. This is from section 4.3. This is the standard 30, 60, 90 triangle. It has a radius of 2. This shorter side, next to the 60 degrees, is half of the hypotenuse, so it's 1. And then this is the square root of 3. This is the standard 30, 60, 90 triangle. So that's what I'm talking about. That's the standard 30, and we have a standard 45, 45 triangle. Not 45, 45, 90. And that was also in the slideshow, and I didn't post it here because I thought it confused you because this worksheet didn't ask about that one. So, but this is the standard 30, 60, 90. So on problem, so I'm just going to spend a minute to talk about, okay, so this is the standard 30, 60, 90 triangle. And let's see, I think I have a blank copy of the worksheet to show you. So, So you're supposed to use the standard 30, 60, 90 triangle in the first question. And you're going to get a value of sine 60 and secant 60 degrees. Now, I'm asking what would have to be done to make the standard triangle so that it would be on the unit circle. So on the unit circle, what I mean is that we're interested in 60 degrees. So I'm going to draw a unit circle here. That's a circle. Oh, just a second. And this is 60 degrees. So you have to come, this will be 1. And you have to come straight down. And that's a right angle. Don't go out to here. You have to come straight down. This is a picture I was looking for. And so, on a 30, 60, 90 triangle, the shorter side is half the hypotenuse. So this is a half. So you have your standard triangle. How would you get from your standard triangle, if I draw it the same way, was 2, 1, square root of 3. So what would you have to do to all of these values so they come out right on this triangle? This is what would have to be done. You have to divide by what? 2. That's all. It was a concept question. You divide by 2. Okay? So, and then you're supposed to find the sine of 60 and the secant of 60. And because they're similar triangles, you're going to, what are they going to be? Okay, and that's the concept on that. We have somebody here to tell us about the Learning Center, so come on out.
Hi guys, my name is Liz. I'm from the Learning Center. We're located in the library in L103. We offer free drop-in tutoring for math, science, and English classes. I have this lovely little handout I will pass out. Tells you how to get to the schedule online. You just look up when a tutor is available for whatever subject you're working on and drop in and see us. It is free. You do not need an appointment. We tend not to bite. So come see us. We also do you guys use Shobi at all?
Yes, we use Shobi all the time.
We have Shobi tutoring Tuesday through Saturday from 9 p.m. to 10 p.m. You can ask your question outside of that time frame, and she will just answer it the next time she's live. But if you are on during that time, it's basically live tutoring. She types an answer, you type a question back, that kind of thing. The course code that you need for Shobi is what we're going to get this one. T as in Tom, 9, Y, 4, M as in Mary. So as long as you add that class, it should pop up and you can ask your question and she'll get back to you the next time that she is live.
Okay, so all you do is click when you're logged into Shobi, join a new class and join this. There's no harm in doing that. It's free. And send Danielle a question. It's Danielle that does it. Okay, thank you.
Thank you.
All right. So maybe I should join that so I can get help.
Yeah, I thought you had times.
You had to. Oh, okay. We can fix it. It's due tomorrow. Okay. You can delete old pictures if you want, or you can just keep adding. I'll try to figure out what you need.
Just look at the dates, that's all you got.
Yeah, I'll do the latest one.
Just change the title of the picture. I guess this is the right one.
Oh, you can change the title to this is the right one. There you go. Thank you. Something to help me out.
Or just put not this one.
Or not this one. Yeah. All right, so I'm going to write down that code. T9Y4M. And I'm not going to be available between 9 and 10 every night. So, so this is a good option. So, all right. I was still in class at 9 last night. All right. Then I was driving home, so. All right. So, do we have any more questions about this homework worksheet? No? Okay. I appreciate you working hard on these worksheets because they're going to help you understand it. If you just sit here and listen to me lecture and don't try to do it, you're not going to get it. So that's why I do these worksheets. And it's more work for me to do them. We are on 4.4 and on number 15 and section 4.4. Now, I've been debating on whether to delay the test today. Yes?
That sounds fantastic.
No, we can't do that. Okay, so here's the problem. We got so much we need to cover, and then we got so much time. But we also don't want to give a test before you're ready. I think we'll delay it to Thursday, maybe 2 more days. And since most of you haven't done but I really, this other worksheet, I'm going to delay when it's due. So 4.3 and 4.4 is a much easier worksheet, I think, but not hardly anybody's turned it in. So, but I don't want to change it to Monday or something because I can change it to Sunday. I want to grade it. A 4.3 and 4.4 homework preview worksheets. I just changed it to Sunday. Why not Tuesday? Because I have trouble grading it on Tuesday. And, I've graded Sunday afternoon. And if it does get collected and I haven't started grading it yet, I'm not going to close it till I start grading it. So I close it to either lock or view only when I start grading it. Because people can take pictures and send it to their buddies. And anyway, I don't think it's a hard worksheet it's actually just over 4.3. I don't know. You guys all know how to use the Pythagorean theorem. So on number one, you're going to use the Pythagorean theorem to find the missing side. So this is actually much easier than the previous worksheet. On number two, if you have a cosine of theta equals something, and we want it to the nearest 10th degree, what function are we going to use in the calculator to find theta? Let's bring the calculator up. Maybe you guys don't know what. We only went over this once, yeah. There is a lot. Okay. So, let me see. Let me get a piece of paper somewhere. I'm not going to work that problem, but if you have tangent inverse of theta equals 0.6421. I just made up a number. You got that? Oh, tangent. Sorry. Tangent. Okay? We want to use tangent inverse. Now, this is a number, and we will get, and if we want degrees, we have to make sure our calculator is in degree mode. Make sure the mode is set to degrees. So, say I was going to do this problem, and what does tangent inverse mean? No. No, did you say that's a... Okay, let me write that out. So, the inverse tangent or tangent inverse means of theta, of the number. Like that. Means the angle whose tangent is x. It's also, you may see it as arctangent on a calculator. That is the same as the inverse tangent function. And it does not mean 1 over tangent of theta or x or theta. So, it means an inverse trig function means the angle whose, whatever the trig function is, it's the angle. So, inverse tangent of x means the angle whose tangent is x. So, the other thing students do in this class is they get confused between angles and numbers. So, tangent theta equals this. This is a number. And of course, theta is an angle. This is a number. But if you want degrees, you have to have the mode set to degrees. So let's do this little problem here on the calculator. We're going to do second tangent and put in 0.6421. Okay, I forgot to check my mode. I think mode is probably in degrees. Mode was in degrees, so I'm fine. But if it wasn't in degrees, what if I had it in radians? Second, if I have it in radians now, so it's 32.7 degrees and it's 0.571 radians. But you have to, so you get totally different answers depending on what mode the calculator's in. So make sure your mode, if you want an angle in degrees, make sure your mode is set to degrees. If you want an angle in radians, have the mode set to radians. Okay? All right. Is this helping?
A little bit.
Okay.
The worksheet definitely looks easier than the other one.
Oh, this is an easier worksheet. Okay, and I gave you a hint for this one already. And then find the reference angle. This is a section 4.4 problem. The reference angle is, and we'll be doing that today again, finding reference angle. So, finding a reference angle, we're going to be doing some examples like that today. All right? Okay, so our test is Thursday, so that gives us some more time to get this down. Thank you for working so hard on these worksheets. I know it's a lot, but I'm just glad that most of you are turning them in. So. All right. So here we were in section 4.4 on number 15. So we talked about a little bit. Let's just review a little bit that what reference angles are. So I'm going to go to the previous. That's 5, 6, 7, 8, 9, 10. Oh, I'm missing page 11. Oh, well, I'll have to show you this one. Okay, so reference angles. And here's, we're going to draw, oh, I have a slide. Let's bring the slideshow up. I'm just going to bring up the Nearpod here. Just to project, the slides as we go. Visual stuff in this class helps. So, my Nearpod. My library. These don't have a lot of activities in them, but at least I'm displaying the 4.4. 5 lesson. We will use that one. So this was a Shovey code here. Tuesday through Saturday. Okay. And this is a Nearpod. So go to Nearpod and just enter FPAMX. So this was the definition of a reference angle. Oh, no, okay. These were the pictures for the reference angle is the positive, so is the, see, we're having theta be in standard position. So, theta is in standard position. You need to remember standard position. So, standard position has its initial side on the positive x-axis. You need to remember that's standard position. So there's your pictures, but I'm going to draw these pictures again. Okay, so if theta is between 90 and 180, then we draw a picture. We start at the positive x-axis for theta and say it's over here. The terminal side over here. This is theta when it's between 90 degrees and 180. Okay, and I'm kind of drawing it small, but okay, it's a pretty big screen though. So this is theta, this is the reference angle, theta prime, right here. So it's going to be a positive angle. We always write theta as positive, so to get it to be positive, we're going to take 180 minus theta. But you don't have to memorize this, just draw the picture. If you draw the picture, you'll be able to figure out what the reference angle theta prime will be. So the reference angle will be 180 minus theta, but you can just find that from the picture instead of memorizing this. Okay, and then the next one, if theta is between 180 and 270, again, its initial size here, and it's down here somewhere between 180 degrees and 270 degrees. So, there we go. This is theta. This is how we draw theta. Its initial side, and then we draw an arrow where you can imagine taking an arc through that to there. That's theta. So what's theta prime? Theta prime is always formed by the terminal side of the by the x-axis. So here's the x-axis. So we don't go over here with it. We got to go. This is going to be our theta prime right in here, and it has to be a positive angle. So we're going to end up taking theta minus 180, but you can figure it out from the picture. Okay? And then the last example, if theta is between 270 and 360 degrees, this is its initial side, and this is 270 degrees, this is 360. So we're going to go all the way around to this quadrant somewhere. There's our theta. And our theta prime is going to be, this is our reference angle. It's going to be here. Just a little. And it's going to be a positive angle. It's always with the x-axis. So it's good. And it's theta prime is not in standard position. The reference angle is not in standard position. It's going to be the positive angle. It's between 0 and 90 degrees, and it's always against the x-axis, but not always the positive. So you can tell from the picture. So that's a reference angle. So we're going to draw pictures to figure out reference angles. Okay? I didn't have that page. So did you finish copying? You still copying? All right. So we did these. We found the reference angles up here, but you can find them by the pictures. The other thing, we found the reference angles in these examples, but we could find them with the picture, but if it's given you an angle in radians, like this one, I want you to keep it in radians. This class, you're supposed to get familiar with degrees and radians. So if I give you an angle in radians, unless I say to convert it to degrees, I don't want you converting every radian angle into degrees and doing everything in degrees. So, so this is given in radians, so you have to be familiar with the radians, and that's going to be over here. So theta prime is going to be 2 pi minus 7 pi over 4. And here this one was given in degrees, and it ends up being over here, but our reference angle is going to be whatever this is. So we had to figure out that this was minus 240, and if we add 180 to it, we're going to get this angle. This is our theta prime in here. That's our theta prime. In 3.6 radians, we had to figure out that theta went to here, and this is our theta prime from here to here. So we took theta minus 3.14, and that's in radians. Okay? So now we're going to talk about finding reference angles for angles greater than 360 or 2 pi or less than negative 360. So here's how you do that. You find a positive. So this is just, it's adding another step. You have to find a positive angle, say we call it alpha, less than 360 or 2 pi that is coterminal with the given angle. Oh, what if you don't remember what coterminal means? Okay, so well, coterminal means that we draw an axis. If we've got this angle, say 60 degrees, and we draw this angle, which is 360 plus 60 or 420 degrees, those are coterminal. They both have the initial side of the x-axis, and they have the terminal side at the same place, but they have different revolutions. That's what coterminal means. We could also go the other way. We could make it a negative angle in black here. So negative 270 plus 30, negative 300 would also be coterminal. We usually don't do the negative. So that's what a coterminal, that's what coterminal angles are. So then so we find a positive angle less than 360 or 2 pi. So we did some of that. We had to convert from larger numbers or negative numbers, and we did that on the first worksheet, I believe. So then once we find a positive angle alpha less than 360 or 2 pi that's coterminal with the given angle because the given angle's more than one revolution, or it's the negative here, we could have still worked with that, but if it's more than one revolution, we got to rewrite it. And we rewrite and find alpha with it. That's less than 360 or 2 pi.
And then we draw alpha in standard position. And then we use our drawing to find the reference angle for the given angle. Okay?
That's why I reviewed reference angles, he wouldn't have any idea. So, and remember, the positive acute angle, that means it's between 0 degrees, I don't know, I'm using theta, but, and 90 degrees. Or it's between 0 and pi over 2. Angle formed by the terminal side of alpha now, because we made it less than 360. And the x-axis is the reference angle. So we're going to do some examples. So this is adding 2 more steps. Well, 1 more step. You just find a positive angle, draw your picture, and you can find the reference angle. Okay? So find the reference angle theta prime for each of the following angles. So this is more than 360. So, you know, I guess
Sorry.
it's greater than 360, so we want to make it, we're going to, if we subtract 360 degrees, we just, that's going to be between 0 and 360. So 665 minus 360. We just subtract multiples of 360 to get it to be a positive angle, and that's 305 degrees. That's our coterminal angle. That is alpha. That's what we're calling alpha. Okay, now we got to go on a circle, and we're going to go to 305. Well, 270's here. So 15 more degrees than, no, 35 more degrees. It's 305. So here's alpha, somewhere in here. So our theta prime is going to be this. What is that? Well, this is 305. So we're going to take 360 minus 305. You don't, if you can figure it out without writing, minus 305 is 55. Okay, and that's called the reference angle. Okay? All right. So, another example.
Quick question.
Yeah.
How'd you come up with the? Oh, never mind. Never mind.
You got it?
Yeah.
Okay. Okay, I think people are still copying that too. I haven't kept up on the slideshow. Oh, yeah, we're still. Wait a minute. So it is best to draw the picture. You don't have to, then you don't have to memorize all these. What do you subtract from and all that? Okay? Just so the slides aren't showing the pictures, but I like the pictures. Okay? Are we still? Is anybody still copying that? Okay. I'm going to go on to the next one. So another example. Now we're going to have to count in pies. So we got to get used to counting in pies. We got 15 pi over 4. then what's 15 over 4? 15 divided by 4 is 3.75. So we got 3.755. We'll want to keep it like that. And we don't want to write it as a decimal, but to figure out what do we need to subtract? If we subtract 2 pi, that'll be perfect. If we subtract 4 pi, we'll get a negative number. Let's work with positive numbers. So we subtract 2 pi and we'll have a number. So we could either do, minus 2 pi is the same as 8 pi over 4. And that is 7 pi over 4. So this is our alpha. And that's our alpha. And now we're going to draw. Okay, this is pi over 2. This is 3. This is pi. This is 3 pi over 2. And this is 2 pi. So 7 pi over 4 is, right, here's 1 pi over 4, 2, 3 pi over 4, 4 pi over 4, 5, 6, 7. That makes sense. It's between 1.5 pi and 2 pi. Okay? So our alpha is going to go over to here. And so this is our theta prime, our reference angle, and it's always with the x-axis. So we just did pi over 4. This is just going to be pi over 4. Theta prime from the picture is pi over 4. If you want to take 2 pi and subtract 7 pi over 4, you can. But that's our reference angle. All right. The next one, we've got a negative number. We want to make it positive. Minus 11 pi over 3. So if we add 2 pi, well, 2 pi times 3 over 3 is 6 pi over 3. But that's not enough. We're going to get minus 5 pi over 3. I'd rather work with positive angles. You can work with that one, but let's add another 6 pi over 3. That's 2 pi. Is pi over 3. We could work with it as negative. The slideshow, they just added 12 pi over 3, which is 4 pi. They realized they wanted to get at 4 pi. I just did it one step at a time. So I'd rather work with positive numbers. So we're finding a coterminal angle with this, and that's pi over 3. Pi over 3 is the same as 6 degrees. So this is pi over 3. This is already a positive acute angle between 0 and pi over 2. So this is our theta prime. That ended up to be our reference angle. It's after the first quadrant. All right. All right. So number 17. So the values of the trig functions of the given angle theta are the same as the values of the trig function of the reference angle theta prime, except possibly for the sine. A function value of the acute reference angle theta prime is always positive. So, we're going to always have, if you're going to find the function values for theta prime as being positive. However, the same function value for theta may be positive or negative. So, we've got our original angle may have positive or negative. And we can tell that by the quadrant it's in. Okay, so tangent of 120 degrees, and if we draw 120 degrees, our reference angle theta will be 60, or theta prime, I mean, will be 60 degrees, but tangent is negative in quadrant 2. So, tangent's negative in quadrant 2. We can, though, find tangent of 60 degrees. If we want, we can draw, you could use the sine over cosine and use your unit circle. Or we could draw our standard 30, 60, 90 triangle. This is 60 degrees. This is 2. This is 1. This is the square root of 3. You should memorize that. That's the standard one. So tangent is opposite over adjacent. Or you can use your triangle, you could use your triangle that's in the unit circle. But opposite over adjacent is square root of 3 over 1. And that's just square root of 3. So that's how you get. And since tangent is negative in the second quadrant, because sine is positive there, but cosine is negative, that'll be a negative in the second quadrant. So you have to add a negative sign to it. So it depends on the quadrant it's in. So we're going to find, so here's our steps. We're going to use reference angle to evaluate trig functions. We're going to find the associated reference angle and the function value for theta prime. Then we're going to use the quadrant in which theta lies to prefix the appropriate sign. So you're going to look at the quadrant. We had the quadrant. You know, a smart trig class. Let's see. Is that this one? Oh, yeah. So, it may have been the previous one. All right, so we're going to go on. Number 19, last page. Okay. So, this is really important. This is the meat of this section, is being able to put it all together and find these signs of different angles now. We've been able to, okay. So, we're going to put it together. 4-3 notes. Oh, 14 notes. Okay, here it is. All right, in the, our slideshow, the same stuff, there it is. Here's our examples, but I'm going to draw pictures. So, see those. All right, so we're going to use the reference angles to find the exact value of sine of 135 degrees. So, we're going to draw a picture. 80, this is 90.
So we got to go 45 more degrees to get to 135, right? So this is our theta. Theta is in quadrant 2. Okay? We want to find sine of 135. Now our reference angle is going to be this angle. And that's theta prime. And 180 minus 135 is 45. That's a 45 degree angle. Theta prime is 45 degrees. So in the second quadrant, sine is positive. It's a smart trig class. All are positive in the first quadrant. Sine and 1 over sine, cosecant. Second, tangent and cotangent in the third. And cosine and 1 over it, secant, the fourth. A smart trig class. That's how you can remember it. Or you can think of the unit circle, how on the unit circle sine y equals sine of theta. The y value in the second quadrant is positive. So sine is positive in the second quadrant. So sine of 135 degrees is going to equal sine of 45 degrees. Okay? And the reference angle for 45, a triangle for 45, or let's see, I just wrote what it was, either from the unit circle or you could draw the reference triangle. You got it's the square root of 2 over 2. Square root of 2 over 2.
Is that just something you have to memorize?
They recommend you memorizing those, or you can memorize the let's go back to here. Let me go into the test material and show you the slide from 4.3. Well, I may not have it here, but right triangle trigonometry. Okay, so we got all those. Okay, so this is the standard 45 degree triangle. So that's what I was wanting to write down. So if you memorize this, this is, I'm drawing this 45 degree triangle.
each side is 1, and then the hypotenuse would be the square root of 2. That's the standard 45-degree triangle. 45, 45, 90. Whoops. Okay, I'm off. So that's an important slide. If you memorize that, you can find any trig functions for 45 degrees very easily. So, and on the unit circle, you would just divide, to get the radius to be 1, you divide everything by square root of 2. But you don't want to be working with all the square roots, dividing by square root of 2 all the time. So you should memorize this. And then, of course, you should memorize this one. This is the standard 30, 60, 90 triangle, where the radius or the hypotenuse is 2, the shorter side is half the hypotenuse, and then if you use the Pythagorean theorem, you can find that square root of 3. So those are 2 things you need to memorize. So I drew the standard 45, 90 triangle here. So if we want to find sine for this, you should have memorized that sine is opposite over hypotenuse is 1 over the square root of 2. And then you have to rationalize it. So it's the square root of 2 over 2. Or if it's a part of the test, you're allowed to use the unit circle. Just look it up on the unit circle. But there's part of the test you're not allowed to use the unit circle. Okay? Tangent of 5 pi over 4. So my practice counting in pi's. So I'm going to count in pi over 4. This is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So this is theta. Where's our reference angle is theta prime right here. And theta is in quadrant 3. And tangent is positive in quadrant 3. All functions are positive in quadrant 1. What is theta prime going to be? 5 pi over 4 minus pi. It's just going to be pi over 4. So theta prime is pi over 4. Tangent of pi over 4. So tangent of 5 pi over 4 is going to equal the tangent of pi over 4. Because tangent is positive in quadrant 1 and 3. And tangent is opposite over adjacent. So it's 1 over 1 or 1. Okay? If you do that enough, you will have these memorized. Okay? And then the last one, secant of minus pi over 6. If we can draw a negative angle. Here's our theta is minus pi over 6. Theta prime is just going to be positive pi over 6. We make theta prime, remember, a positive acute angle. Okay, so secant is the same as 1 over cosine. So cosine, this is quadrant 4. Cosine and secant are positive. So secant is positive by a smart trig class. So you're gonna write this down on your paper before you start figuring all these out. And secant's positive. Secant's positive up here too, you know. So when we take, so secant of minus pi over 6 is going to equal secant of pi over 6. Alright, pi over 6 is the same as 30 degrees. So let's draw the standard. I'm going to draw it with 30 degrees here. Or pi over 6, which equals 30 degrees. And this is the 1 n squared root of 3.
So secant, well, cosine is adjacent over hypotenuse of secant is hypotenuse over adjacent
Is 2 over the square root of 3. And then we need to rationalize that. So we multiply by square root of 3 over the square root of 3. Is 2 square root of 3 over 3. And it's positive because secant was positive. So you find, you memorize these reference triangles for these common angles, and you got to realize that, and you got to memorize that pi over 6 is the same as 30. Think about that too. All right. Any questions? So we will review for the test on Tuesday and have the test Thursday instead. Okay? Thank you guys. What? Early? Yeah.